But there is no doubt that the motion of objects like apples and the moon captivated Newton at this time. The Italian scientist Galileo had proved in a famous experiment on motion that all objects falling to Earth pick up speed or accelerate downwards at the same rate, regardless of their mass. And finding the average speed of a falling object was a straightforward process. For example, if you want to find the average speed of an apple falling from a tree, all you have to do is divide the distance the apple travels by the time it takes the apple to fall. But Newton was not satisfied with the average. What would be the speed of an apple which is constantly accelerating at every point along the way? What would the apple's velocity be halfway to the ground? To find out, you can measure the apple's average speed over smaller and smaller periods of time. The shorter the time interval, the closer you get to knowing the apple's speed at that moment. But to find its precise speed at a single instant, you have to reduce that time interval as close to zero as you can.
Newton invented a way to make that time interval infinitesimally small. What is infinitesimally small? That is smaller than any number that you can think of. It's not zero, but it is smaller than any number that you can think of.
For the first time, it was possible to calculate quantities that are constantly changing, like the speed of a falling apple at any particular moment, or how a planet's position changes over time. With this technique, Newton invented an entirely new branch of math called calculus.
And that changed all of science, of course. The whole way of looking at the world changed because of calculus, yeah.
Calculus was a quantitative understanding of the way things change. Not just velocity, but in physics, in chemistry, even in populations. How fast is a population changing over time? This mathematical framework becomes the language in which modern science is formulated.
Today, calculus shows up everywhere, from analyzing the stock market to modeling global climate change.
By the time he was 22 years of age, working on the calculus at Woolsthorpe, he was the greatest mathematician the world had ever seen, and yet no one knew. Only Newton knew, and it was his secret.
This was a guy who adored computation of every kind. Among the things that you can see if you open his manuscripts, for instance, is there are places where you'll find he's calculated logarithms out to 50 places and things like that. Not because he needed it, but because he liked doing it. I mean, it was a pleasure to him to do that sort of thing.
And if that weren't enough, Newton overturned accepted wisdom about how colors are produced, performing an experiment on himself with a large needle, or bodkin.
I took a bodkin and put it between my eye and the bone, as near to the back side of my eye as I could. And pressing my eye with the end of it, so as to make the curvature in my eye, there appeared several white, dark, and colored circles.
Fortunately, Newton found a safer way to investigate light and color, using a prism. From Aristotle to Descartes, scientists thought sunlight, or white light, was pure. Colors were produced by physically modifying white light, which they believed passing it through a prism did. But Newton decided to see for himself. Sending sunlight through a prism, he produced the spectrum of colors. And then he went one step further. He sent the red ray of light through a second prism. Instead of making a new color, it remained red. Newton concluded that white light is not pure, but a combination of all the colors of the rainbow.
He thought of the prism actually as a separator of the objects that are all in the original light. This was very hard for almost everybody to swallow, because it meant that when you're looking at white light, you're looking at something which has all the colors already in it. This seemed completely counterintuitive, and indeed, frankly, it's counterintuitive to most people today.
Only 25 years old, Newton had made some of the most stunning breakthroughs in the history of science. But he kept them almost entirely to himself, just as he had done with calculus. After the plague subsided, he returned to Cambridge, where he worked his way up to an appointment as the Lucasian Professor of Mathematics, the position held by Stephen Hawking today. Newton became known for his prematurely white hair and for his long-winded lectures on light.
That belongs to refractions, tacitly founding their demonstration on a certain physical hypothesis not well established. I judge it will not be unacceptable if I bring the principles of science to more strict examination.
The introverted Newton had little time for students, and they had little interest in him. Years later, one of Newton's laboratory assistants would recall,
so few went to him, and fewer that understood him, that oftentimes he did, in a manner, for want of hearers, read to the walls.
But Newton's study of light was about to start a revolution. 50 years earlier, Galileo had built one of the first telescopes. It used glass lenses to gather light from distant objects and focus it for the observer. But this kind of telescope had a problem. Its lenses produced fringes of color around the edges of the objects being observed.
And that meant that the objects that you looked at always had this chromatic aberration. They always looked colored, even when the original object wasn't. And Newton began on the side to make some things with his own hands. And he designed a remarkably and radically different kind of telescope from anything that had been built before.
Newton realized that the edges of a lens behave like a prism, breaking white light into different colors as it passes through. So he abandoned lenses and substituted a mirror to gather and focus light from distant objects. And because the light never passed through a lens, it was free of color distortion. Newton's telescope was only 6 inches long, but Newton bragged that it could
magnify about 40 times in diameter, which is more than any 6-foot tube can do. I've seen with it Jupiter, distinctly round, and his satellites.
It was an instrument that has left its impact on astronomy ever since. Our huge telescopes of today are built on this model. They're gigantic versions of this tiny little thing. These are the telescopes that sit on the top of the great mountain peaks. These are the telescopes that we launch into space to peer into the deepest parts of the visible universe.
Newton regarded his invention as just a toy, but a colleague took it to London, where it was shown off to King Charles II.
The effect that it had on Newton's contemporaries was immediate and dramatic. It brought Newton onto the world stage of science, and Newton became an overnight sensation.
Newton was elected a member of the Royal Society, a group of leading scientists in London. Most of them were awed by the whiz kid from Cambridge, and Newton was so delighted that he promised to send the Royal Society a paper he had written on his discovery that white light is made up of different colors. But members of the Royal Society had no idea that Newton was studying something far more mysterious than light by this time. His private notebooks reveal that the same year he became a professor at Cambridge, he bought 2 furnaces, an assortment of chemicals, and a strange set of books. Isaac Newton had become an alchemist. Alchemy is an ancient and secret practice with roots in the Middle East. By carrying out lengthy and complex chemical procedures, alchemists tried to produce a magical substance called the philosopher's